Hello, 7th graders. Welcome to Chapter 2. Lesson 2.1 is going to be broken up into 4 parts. It's going to be called Parts A, B, C, and D. And right now we are looking at 2.1a. Understand that these 4 parts are all part of just Lesson 2.1. Before you begin, please be sure that you have your notebook and a pencil. Take notes and complete all the examples. And when you're finished, please be sure you complete the assessment at the end. So our goal for today is to learn how to convert fractions to decimals. And we will eventually be able to answer our essential question, how can you use a number line to order rational numbers? Here's some vocabulary I'd like for you to write down, so if you need to, please be sure you pause the video. A terminating decimal. To terminate, any of you who have seen the movie The Terminator, Arnold Schwarzenegger had a goal to end someone's life or to put a stop to. So terminating, not so graphic here in math, means it's a decimal that comes to an end. All right, that decimal stops. And here are some examples of terminating decimals. Repeating decimals is exactly what it sounds like. It's decimals that repeat in a pattern and they never ever stop. And here's some examples of repeating decimals. Notice negative 1.333 is rewritten as negative 1.3 with a bar over it. The bar notation shows that the digit 3 repeats forever and ever. And if you look at the next example, 151515 will repeat forever. So we use bar notation to show that the 1 and the 5 will repeat continuously. Terminating and repeating decimals are just some examples of rational numbers. Okay, here in example number 1, we're going to take negative 2 1/4 and rewrite it as a decimal. So the first thing we do is take negative 2 1/4, and one way we can do this is make the mixed number an improper fraction. So we're going to take 4 times 2, which gives us 8, add 1 gives us 9. So our improper fraction would be negative 9 over 4. So what we're doing now is taking 9 inside and dividing it by 4. So question for you, how many times does 4 go into 9? If you need to, take out your multiplication chart and use that. So 4 goes into 9 2 times. So what is 4 times 2? We have 8. And when we subtract 9 minus 8, we get 1 and bring down a 0. How many times does 4 go into 10? We get 2 again. 2 times 4 is 8. When we subtract, we get 2. And then we bring down the next 0. How many times does 4 go into 20? We get 5. 5 times 4 is 20. There's 0 left over. So the 0 means no remainder. So if I take a look at my solution, 2.25, is my answer supposed to be positive or negative? Well, if you take a look, I started with a negative number, so my answer will be negative 2.25. So is this decimal a terminating or repeating decimal? And the answer is terminating, since the remainder is 0. In this next example, we're going to write 5/11ths as a decimal. Remember, it's 5 being divided by 11. Right? A lot of students want to write the numbers the opposite way because in elementary school we learned that the bigger number goes inside. That's not true. The top number, the 5, is called the numerator, and the bottom number is called your denominator. So the denominator always goes outside. So let's take a look. Can 11 go into the number 5? And I'm sure all of you answered no, so you are welcome to add a decimal point and 1 0. From here, how many times does 11 go into 50? And I hope you are saying 4. So 4 times 11 is 44. Subtract 50 minus 44 to get 6 and bring down your next 0. How many times does 11 go into 60? I hope you are saying 5. So how many is 11 times 5? We get an answer of 55. Subtract to get 5 again and bring down a 0. How many times does 11 go into 50? Hopefully you have said 4. 4 times 11 is 44. When you subtract, you get 6 and bring down the next 0. How many times does 11 go into 60? We get an answer of 5. 5 times 11 is 55. And we have a remainder of 5. Do you notice that the numbers in here, in here, in here, and if I added another 0 in here, that the numbers are continuing to repeat? And if you look at your answer, do you notice that 45 repeated again? We have 4, 5. So it looks like this pattern will repeat forever. So our solution is 45 hundredths. We put a bar over both the 4 and the 5 because both of those digits repeat. Since the numbers are repeating, what kind of decimal is this? Repeating, since we have a remainder. So what you're going to do now is take these 4 examples and write them down in your notebook. And I would like for you to divide these out and convert each of these rational numbers into a decimal. What I'm going to do from here is show you the solution. Please be sure you pause at this point if you haven't completed the 4 questions. And on the next page, I'm going to walk you through step by step on what the steps would be. So number 1, your solution is negative 1.2 or negative 1 2/10. Number 2 is negative 7 375 thousandths, tenths, hundredths, thousandths. Number 3 is negative 27 hundredths repeating. And number 4 is 1 185 thousandths repeating. So let's take a look at the next page at all the work. All right, I'm going to go through all the steps with you. Okay, remember, negative 6 is being divided. Let me change the color. Negative 6 is being divided by 5. So 6 is being divided by 5. And I worry about the sign up here next to the problem. I just put the negative sign up here, and when I'm done with my answer, I'll just plug it right in here, just so I don't have to worry about the sign while I'm working. Sorry, I'm using the touchpad here on the laptop, and it's not that easy to write with. How many times does 5 go into 6? 1 time. Okay, 1 left over. Now that I'm at this point, I will add a 0, a decimal point, and a 0. How many times, bring that 0 down, how many times does 5 go into 10? 2 times. And how many do I have left over? 0. My decimal point goes straight up. Remember, I have a negative, so my final answer is negative 1.2, or 1 2/10. right, for number 2, we have -7 and 3/8. I know my whole number is going to be -7. That won't change. So what I'm going to do is work with 3 divided by 8. So when I write that, 3 is being divided by 8. Okay? How many times could 8 go into 3? And hopefully, sitting at home at your computer, you're saying no times. Right, this is a 0 here. How many times could 8 go into 30? Well, 8 times 2 is 16, 8 times 3 is 24, and 8 times 5 is 40, so 3 would be my best answer. Okay, so I'm going to put a 3 here. I don't know why this isn't working nicely. Okay, here we go. So 8 times 3 is 24. When we subtract, we get 6 left over. I could add a 0 up here. And I'm going to bring this 0 down. Okay, so now how many times does 8 go into 60? And the solution would be 7, because 8 times 7 is 56. And when we subtract 56 from 60, we get an answer of 4. I think I'm going too fast for the computer. We get an answer of 4. And then we add another 0 at top. And we bring that down. And how many times does 8 go into 40? We get an answer of 5. And 8 times 5. Well, it's going to have to stay there. 8 times 5 is 40. So my final answer will be -7 and 375 thousandths. Okay, in this next example, we have -3 being divided by 11. So that means the 3 goes inside the division house and the 11 stays outside. Remember, your denominator always stays out. Okay, I think I solved some of the technical issues, so let's take a look. We have 3 being divided by 11, so let's ask ourselves how many 11s go into 3, and the answer is 0, so we need to add a decimal point and a 0. And now ask yourselves how many 11s go into 30, and the answer is 2. 2 times 11 is 22, and when we subtract, we get a difference of 8, and then we bring down the next 0. So write a 0, bring it down. 11 goes into 80 7 times. 7 times 11 is 77, and when we subtract here, we get 3, and add a 0, bring that down. And how many times does 11 go into 30? Hopefully you said 2. 2 times 11 is 22. When we subtract, we get an answer of 8. We could add another 0. If you notice, the pattern's just going to keep going. 2, 7, 2, 7, and so on. So our final answer, 3 over 11 equals -27/100ths, repeating. Okay, for the next example, we have 1 and 5/27, and I know that the whole number is going to stay the same, so I'm just going to bring the -1 over, and what I'm going to do is take 5 and divide that by 27. So I know most of you are looking at this and you're like, forget it, I can't multiply by 27 or divide by 27. So what we can do, and please make sure you write this in your notebook, I over here under the green have listed all the facts 1 through 9 for 27. So 27 times 1 is 27. Please make sure you copy this chart. So anytime you have a fact that's too hard, just make yourself a list so you don't need to constantly rewrite all the facts. So there you go. Okay, for this next example, now that you have your list of the 27 times tables, can 27 go into 5? Hopefully you are saying no. So we're going to add a decimal point and a 0. And now ask yourself how many times 27 times what will give you 15. If you look at your chart, the only one close is times 1 because times 2 is too big. So 27 times 1 is 27. When we subtract, we get 23. We add in another 0 and bring that down to get 230. If we take a look at our list, 27 times what is about 230. And we get an answer of 8. 8 times 27 is 216, which is right over here. And when you subtract, you get an answer of 14. Add in a 0. Now ask yourself how many times could 27 go into 140? If you look at your list, the closest would be 5. 5 times 27 is 135. When you subtract, you're going to get 50. And if you notice, I started with 50 back at the beginning. So that means this pattern is going to constantly repeat over and over and over. So my final answer is 1 and 185 thousandths repeating. Okay, now we're going to go to the next page. If you need to pause this and write any notes down, please go ahead and do so. The next page will have some sample problems for you to try. All right, take a few minutes. Write numbers 1, 2, 3, and 4 down. These won't be as long as the examples we've done together, and we'll go over these in just a minute. Okay, for number 1, we have 7. 7 is being divided by 8. 8 can't go into 7, so we add a decimal and a 0. 8 times what is close to 70? Use your multiplication chart, and we get 8. 8 times 8 is 64. When we subtract, we get 6. Let's add in a 0 and bring down. 8 into 60, we get 7 times. 8 times 7 is 56. We get 4. We could add a 0 and bring down. 8 into 40 is 5 times. 8 times 5 is 40, so we get 0 at the end here. So 7 over 8 equals 875. 875 thousandths. For number 2, we're going to take 5 and divide that by 11. How many times could 11 go into 5? Hopefully you're saying none, so we add a decimal and a 0. 11 goes into 5 a total of 4 times. 4 times 11 is 44. We have a total of 6 left over. Add a 0 and bring down. 11 into 66 is 5. 5 times 11 is 55, with 5 left over. We add another 0 and bring down. If you notice, we start with 5 back at the top. 11 goes into 50 4 times. Do you guys see how the pattern's repeating? We're going to get 44, and we're going to continue to repeat. So number 2, 5 over 11 is 45 hundredths, repeating. For number 3, we have negative 7 over 9. So 7 is being divided by 9. And I'm just going to put my negative here in the answer and worry about it later. 9 can't go into 7, so I add a decimal and a 0. 9 goes into 70 7 times. We get 9 times 7 is 63. 7 is left over. You should notice the repeating pattern already. I have 70 again. 9 times 7 is 63. I get 7 again. So we're just going to go in circles. So my final answer is 7/10 with a bar over it. All right, and for the last one, I have included for you all the facts of 40. Please be sure you write this down. And we're just going to divide. 17 is being divided by 40. So 40 cannot go into 17, so we add a decimal and a 0. And if you take a look at your chart, how many 40s can go into 170? And we get an answer of 4. 4 times 40 is 160. We subtract. Whoa, what happened there? We subtract and get 10. Add a 0 and bring down. Not sure why all that's moving. How many 40s go into 100? We get 2 to get an answer of 80. Subtract, we get 20. Add a 0, bring that down to get 200. 40 into 200 is 5. And we zero out here. Decimal point goes straight up, so we get an answer of negative 425 thousandths. All right, congratulations. You've reached the end of video 1.2a. There will be 3 more to follow. You do not watch them today. Please go to your video assessment.